So AP Calculus, AB, find the area bounded by f of x is equal to cosine of pi x, and the graph of g of x is equal to 0 on the interval from 0 to 2. So first thing I did was I tried to look at it, and then I realized there was going to be some trouble. So this is what I tried to do first. I set up my Cartesian plane like this, Kenny. And then I asked myself, what happens here? What happens from 0, and let this be 2 out here, to 2, right? So this is what I found out, right? Remember, we're bounded by this x-axis. So this is what I found out. I tried to figure out what are the intercepts here. So I tried to figure out when is cosine of pi x equal to 0. So when you ask yourself this question, you have to kind of be at the unit circle asking yourself the question. So for what values of cosine or have a cosine value of 0? So what I did was I was here. I said, look, pi halves and 3 pi halves, right? So that's what I did. I asked myself, when does pi x equal, right, pi halves? You with me? From here, I divided both sides by pi and got x is equal to 1/2. I'm going to call it 0.5 for now, if you don't mind. So 0.5. So 0.5. So right here is 0.5. Because what I'm going to do here in a second is I'm going to try to build this graph, right? I'm going to build the graph like the one that we built before. I also know by looking at the unit circle that cosine of 3 pi halves is equal to 0, isn't it? So I asked myself, when does pi x, this pi x, when does pi x equal 3 pi halves, right? Multiply by the reciprocal here, otherwise known as divide by, right? And you can see, Joy, that the pi values cancel out, don't they? So 3 halves, or 1.5. 1.5, right? We know that cosine of 0, if I put 0 in here, I get pi times 0. Cosine of 0 is what? Right there on the unit circle. Cosine of 0 is 1. So all I'm going to do now is I'm going to draw my graph in here. So here's the graph now. Let's let this be 1 if you don't mind. This is going to come down through here, go all the way down to -1 and over to here. So this is the graph. This is what I'm looking for, right? We said we need to look from 0 to 2, and that's what happens from 0 to 2, isn't it? But look at this for a second. This is where they're going to get you on the AP exam. They're going to get people, just not you guys. They're going to try to get us here because this is area over the x-axis, isn't it? So this is going to, people are going to think, well, this is positive area. This is positive area, isn't it? Say, okay, well, we have these two pieces. But what about this piece here? What is somebody liable to think about this? Can you see how a person might think this is negative area here? Because it's under the x-axis, it's not negative area. But if you put in this notation into your calculator and you say to your calculator, what is the definite integral from 0 to 2 of cosine of x dx, then what your calculator will do is it will add this area plus this negative area plus this negative area, and you're going to get the wrong answer. And that's what they're going to be looking for you to do on the AP Calculus exam. So what we'll do instead is this. We'll look at this and we'll set this up differently, and we'll say this. Here's the positive area. So here, from 0 to 0.5, right? If you look up here, we see that the area is positive here, isn't it? And that's because we have cosine of pi x over the line x equals 0. Don't we? I'm sorry, y equals 0, don't we? Dx. But if you look at this one, look, remember, this line is the function g of x is equal to 0, isn't it? And from here to here, isn't this line right here on top of the function? So now we have from 0.5, from x is 0.5 to x is 1.5, we have 0, the function g of x equals 0, over cosine of pi x dx. Don't we? And then lastly, in this interval here, from 1.5, Jimmy, to 2, remember we only care about it from 0 to 2, right? Here we have, look, cosine is, look at this for a second, Jimmy. Cosine is on top, isn't it? Cosine is over this, so that's what we're going to say. We're going to say that cosine of pi x is over that function, dx. All right? And from here, we can start doing some integration. Actually, we're going to integrate here. Yeah, let's do our integration now. So we're going to integrate this function. So to start trying to integrate, we're going to have to do a little u substitution, because remember that our function is cosine of pi x. Right? So we have this function here, cosine of x dx, from 0 to 2. We have to be very careful about what this really means to us. Right? So what I'm going to do here is I'm going to let u equal pi x, du equals, the first derivative of pi x is pi, dx. What I want to do is, look, right now, I can take this out just to show you where I'm going with this. I'm going this. Right now I have cosine of u dx. So what we have here is a function, Kenny, that is mixed. It's in the form of u and dx. That doesn't help us. So we want to get everything in the form of u. So what I'm going to do here is I'm going to divide this side, both sides by pi. So divided by pi, and look, we get dx is equal to du over pi, don't we? So now we can do our replacement here. I'm going to replace dx. It says here dx is, Joy, is du over pi. So we have du over pi on our interval AB. All right? Look at this board right here. This board right here, this is where I'm going. What I'm trying to get to is this. I don't know if you can see it. That's what we're trying to get to, and we just got there. So now we can actually do our integration. So we're going to integrate this by parts, right? And remember the parts that we broke out. So the first thing I'm going to do is I'm going to take this 1 over, see the 1 over pi here? I wonder if you can see that. See this 1 over pi. Can you see it? I'm going to bring it out here and say this is 1 over pi cosine u du. From here, I'm going to start to integrate. I'm going to do 1 over pi times the first integral of sine of u, of cosine of u is sine of u. So sine of, and we know that u is pi x. And we're going to look at that from, right, we said 0 to 0.5, is that right? Right? Minus, and this minus sign, just to tell you, is this, right? Look at this for a second. That, the minus sign that I'm putting in here is this one from here. Because I know I'm going to have negative area, so if I take negative area, negative is, that's how I'm going to get that area to count as positive, right? So you have to be really careful here. And we looked at it and we said it's sine of pi x. And this right here, these are the lower and upper bounds. So I'm going to go from 0.5 to 1.5. Look at the graph for a second. See why we're doing that? Because here is where we think, I'm nervous, Terrell, that it's going to show up and look like it might be negative area. And it's not negative area, right? Plus, and then Terrell, we're going to go to this last piece right here, aren't we? And that's all over the x-axis, isn't it? So plus sine of pi x from 1.5 to where? So yeah, of course, to 2. From there, we would use the fundamental theorem of calculus. So we're going to take FTC, the fundamental theorem of calculus, and as we apply the fundamental theorem of calculus, it would break out and look like this. I'm not going to do all this math with you guys, but this arithmetic. 1 minus 0 minus negative 1 minus 1 plus 0 minus minus 1. If you could fill in the intervals, you'll see why all that's true. And when we got through with this, when we added all this on the inside, we'd get 4. But remember, Terrell, right here we have this 1 over pi, so we get 4 over, exactly, we get 4 over pi as our final solution. If you're taking the AP exam, even if, on the free response, even if you could use your calculus, this is the work that you should show. And please, please remember always that be careful that if you just ask your calculator this question, you're going to get the wrong answer. So be careful. So this is my warning to you, to be careful and make sure that you are integrating by parts. All right?